And loop number 4 is the domestic hot water loop, which takes water from the domestic hot water tank through to the water refrigerant or desuperheated coil and heats that. Now we have optional on this particular drawing, but in most residences and residential kind of equipment, all systems would have that, and that's probably not an option that you would not want to give to your customer, because that's a real money maker for them. Because in the summertime, that thermal energy that's coming off of the refrigerant system is going to be wasted underground. You might as well use that to heat water, and so a lot of times that will be marketed by the manufacturer or your dealer as free hot water. So it is free. You just have to air condition your house. So if you're air conditioning your house, you might as well take advantage of that. That's the refrigerant cycle for the heat pump operation, and it just continues to go and go. During my career, which is in the ground source heat pump business, spans around let's say about 25 years. I had a partner of mine who installed one of these in his house, and he was an engineer, so the first thing that he did was he put an hour meter on the compressor to see how many hours this thing was going to run. And so you can imagine this thing's running 2,000 or 3,000 hours a year. It's over a 20 to 25 year period. You get 50,000 hours on one of these things. That's a lot of hours. Same heat pump, same ground heat exchanger coil. He told me that he had replaced a couple of contactors that were used, that are in the system to start the electric cycle going. So that's a lot of hours, 50,000 hours. No maintenance other than changing filters and then replacing those two contactors. So whenever you're looking at comparable systems, or you're trying to sell your system over something else, you want to take into account these things are good for a long time periods. Now, and the other thing is that we tell a lot of dealers, you better get your money when you install these things, is because you're not going to make a lot of money on maintenance, because the only thing that you have to change in one of these systems right here are the air filters and occasional maintenance on some of the electric components, which are not generally not very expensive. Now, in the heating cycle, the heat pump operation is a lot like the cooling operation, except now for the heating cycle, we do the same thing as far as the hot gas coming off of the compressor goes to the desuperheated coil, and we take off some heat from the desuperheated coil, and then after that, that hot gas goes into the indoor air coil. Now, in the cooling cycle, that was the evaporator. Now the roles are switched, and that becomes the condenser. That's a hot gas in that coil, and that's what you want to have in the wintertime. The return air is then moved past the hot gas coil, and the air comes out of there warm. Now, people say, well, now, heat pumps always have cold air temperatures. Well, ground source heat pumps, a lot of times the air temperature coming out of there is around 100 and 105 degrees Fahrenheit. Now, you don't want to get it a lot warmer than that, because you can make that air coming out of there warmer by slowing the fan speed down. Well, that decreases your efficiency some, but a lot of times if people talk about complaints of cold air temperatures on a heat pump, is that first thing that you ought to take a look at is the fan speed. It may be that you have it cranked up too high, and therefore the air coming out of there will be cooler than if the fan was operating at a lower temperature. So now we have the refrigerant now coming back to the expansion device. That expansion device now is going to drop the temperature. It's going to go over there to the ground loop coil, and it's going to then be evaporated by circulating warm fluid from the earth across that cold liquid that's now in that coil. Coming out of there is a cool vapor coming over the compressor, being compressed, and then the cycle continues, and that continues. And like I said just a little bit ago, that's happened for 50,000 hours in this one particular heat pump. Now, I know there are heat pumps that have run longer than that. It's not a world's record, but it's not bad for Stillwater, Oklahoma. Now, the other systems that operate with ground loops and have operated very successfully are hydronic systems, and this is where we're going to replace the indoor fan coil with a water coil, and we're going to circulate heated water underneath the slab of a residence, a commercial building, whatever the case may be, or in agricultural processes where we might be raising fish, we might be in farrowing pens for pigs or hogs, any place. And that particular system is very, very efficient because the delivery temperature that you have to have in a hydronic system is lower than the delivery temperature that you have in an air system. So if we're talking about a COP of 3.5 for an air delivery system, we can talk about a COP of a hydronic system at least a 4.5 and maybe even 5, because the floor temperature or the temperature going to the coils underneath the floor are somewhere around a 90 to 100 degrees Fahrenheit, which is relatively close temperature to the ground temperature. So that makes the system more efficient. Now, I really believe in that residential system with the coils underneath the floor, because of my own residence I have that, and believe me, nobody brags on that system more than my wife, because it's just unbelievably comfortable inside the home. You know, it can be 20 degrees outside, and my wife is walking around in her bare feet. I mean, just kind of like a nice summer day. Very, very comfortable, because the floor is not hot by any means. It may be 85 degrees, and so it's a very, very comfortable temperature. But from an engineering standpoint, and the way I look at it, it's very, very efficient. I know, and people say, well, that's not going to be used too much in the southern climate like Oklahoma would be, but because of its comfort, it's so much better than an air system. Then you're seeing a lot of these installed. I know that I don't know how many were installed in Stillwater, Oklahoma when I did mine with a heat pump, but I didn't know of any, but now there must be a half a dozen or so, and that's increasing a lot more. A lot of times these are in the upscale housing markets, but its economic advantages are in any number of systems. And this shows, for those of you not familiar with radiant floor piping systems, you see here the advantages that you have when you circulate that water in the floor, or this shows you, I guess, a concrete slab. You have a higher heat pump COPs, 4, 4.5, maybe even 5. If you control that water temperature in the mild part of the winter time, you can run it even lower than 100 degrees. You can probably run it at 90 degrees. The other thing that you have about the water-to-water heat pump is zone control. You are able to have multiple zones in your building load. And in my house, I have 5 different heating zones. We like the bedroom cooler than the living room and the kitchen and the laundry. So you have all of that. But like I said, if you've never been around a hydronically heated floor system, take the time, go find one, because I think you'd become just as mouthy about it as I have. It's a very good system. Applications: floor heating, ice melting, water heating if you have big water heating loads. Water-to-water heat pumps are the way to go. Now, we talked about the cooling cycle before. This is just another representation that doesn't have the ground heat exchanger on it. You can see the rolls, and here we've identified the condenser and the superheated coil and the evaporator up there. The evaporator and condenser coil are going to change roles between cooling and heating. The system is very, very simple. It's a basic refrigeration system. Your refrigerator operates the same way as this heat pump operates. The only thing that is going to be different is that, and I tell people it's like a refrigerator. In the summertime, we live inside the refrigerator. In the winter, we live on the outside of the refrigerator, because the heat that's taken out of the refrigerator is put in the room, and so that's the way the thing operates. The roles are changed in the heat pump between heating and cooling by the refrigerant reversing valve.